Okay, so hello everybody. Thanks for coming along. So we are having a little panel talk here about the power of on-prem. And I'm very honored to welcome our guests here. So to my right, we start with Sean Valley, VP of Business Development at Ampere.
Yes.
Thank you.
Thank
Then
you.
we have Alex Liu, coming from Ampere as the COO.
Yeah, from 19th.
Nadine, what did I say? Did I say Ampere?
Yeah.
Okay, that works quickly. Okay.
Yeah.
So, NetEnt, of
Yeah,
course, yeah.
yeah.
And then we have Steve Strong, CTO of Norsk and Ideas. Okay, got it. Thank you very much. So, I like to talk about the power of on-prem. So, let's start with what is on-prem actually, because some people say the cloud is just somebody else's computer. So, what are your thoughts on how would you define on-prem? What's the special angle to that? Steve, do you want to say something about that?
Sure. Is this?
I can move around the mic. That's easier. So I give you the mic.
Yep.
Hello. Yes, that's a lot better. So for our customers, on-prem is about them having control of their assets. So having their own hardware, whether that be hosted on-prem in their offices or whether that be hosted at some hosting center, isn't really relevant. But it's that they've got a certain stack of hardware. They know the assets. They know what's inside it. They're in control of the spec, the specifications, the cards they're running inside, the CPUs, the disks, they're in control of everything. And importantly for them, they're not renting it. They own the assets, so they have a fixed cost base. It's a CapEx versus an OpEx deal. And yeah, to our customers, they run a lot of on-prem stuff, and it's about 50-50, I'd say. It's mainly having that control over the spec and the cost.
Okay, and with 50-50, you mean so 50% of your customer base is running on-prem and the other half is running in the cloud then?
Yeah,
Okay,
that's right.
okay, okay, got it. Okay, so it seems it's not so much of a location, it's more of a question of ownership and of the economics. So Sean, we talked about it earlier. Could you share your view on the economics and on the models that are available? Because usually people think that cloud means you rent something, on-premise you buy something. There are different angles to that. So would you mind?
Yes. Yes. Is this working? Yeah. Okay. Actually, this one's working. All right. So yeah, that's a really good question. I think one of the things that really kind of comes down to is that traditionally cloud has been looked at as an OpEx type of spend, right? Where you don't have to own the infrastructure, and maybe you don't have to own all of the platform, right? You can kind of put what you want onto these hardware servers and other infrastructure in the cloud without having to bother with a goodly portion of the stack, and so that has evolved from infrastructure as a service to platform as a service to software as a service and all of those sorts of models of cloud. And so when you talk about cloud, it's not one thing, right? There's a lot of different models. But on-prem is as Steve described, really still your own bespoke infrastructure, right? You usually have to manage all of it from the very, from bare metal all the way up. But now what we see that I think is also starting to evolve is like a colo type of model where you still own the entire infrastructure, but you don't own the data center, you don't own the concrete and the power facilities and all of those sorts of things. So the models are all blending, as we go, but that on-prem now has taken that sort of shape in a lot more, especially in CDN, where people are spreading their infrastructure, right, into a lot more edge-oriented data centers. So we see that kind of on-prem going in a lot more edge locations.
Okay, so Alex, from your side, what is your view on that? So if we look at NetInt cards, are they being used more on-prem, in the cloud? What is your angle to that?
Yeah, so, it's quite a lot. So to me, I think on the cloud or on-prem, that is both quite a sweet spot for us. But consider the scale of the business model. To be honest, so most of our products is shipping to the cloud data center. So if you compare to the volume split, maybe 90-10 or 80-20. But we do see there's a trend, more people choose to on-prem because they have the ownership, they have the control, and especially the different business model and the control make them have the way of the innovation, right? For example, they want the latest hardware, they want the latest acceleration cars or whatever they want. They have the control to do that easily. But if you talk that on the cloud, maybe it's spend 3 years, 2 years, right? So that's kind of a control that empower the companies to move more workload on-prem. Of course, the business case is another big factor.
Sorry, could you repeat the last bit? What is the big factor?
One is the innovation of the control. Another one is the business, right?
Okay.
On their different cost models.
Mm-hmm.
Yeah.
Okay. Okay. So, and if you look at the invest that people have to do there, OPEX versus CAPEX is a big question here in that area. But I think the important part is that this is not a clear distinction anymore, because there are you have that way where you can have multi-annual contracts with a cloud provider that bring down your costs because you have some commitment, and on the other side you can have rental agreements on equipment that you traditionally would have bought. So is that something that you also observe, no, Sean?
Absolutely, yeah. We see all sorts of creative agreements going on, and I think I agree with Alex that you know the on-prem, I think, is more about really tuning, right? Being able to tune bottom to top stacks in a way that you won't get necessarily in a public cloud infrastructure. Certainly because a lot of that is not available to the implementer or the enterprise.
Okay, so because if you go to off-the-shelf cloud services, not everything you might need is available, no? So,
yes.
So the customization is a huge topic there, no?
Right.
Okay,
right.
absolutely, yeah. On the other hand, when we talk with customers, a lot evolves around the topics of sovereignty. So it's not so much that they need the physical control about that, it's more like they want to be in the legal framework that is relevant to them. So for instance, they need everything to be placed within the European Union or even in a certain country, which brings its own difficulties with it, because the internet doesn't care about country levels, it's just a bunch of autonomous systems that cooperate together. No? So that's a different angle than that we have here.
Yep.
What are your experiences with moving between on-prem and cloud? Because we see that there are not use cases that you can cover either on one of the two locations. So usually people want to have a mixture. What are challenges that you see when you move between different cloud providers, and if you have on-prem infrastructure? Perhaps, Steve, if you have something about that.
Sure. So, yeah, we'll go for that. There we go. So I'm from Norsk. We're very much a software-based company, so our software can run anywhere. And what's really nice with that is it lets you run a media workflow in your on-prem kit, and you can run the exact same workflow up in the cloud. And if there are differences in the infrastructure, for example, on your on-prem kit, maybe you've got a bunch of NetInt cards and you're using those for your transcodes, and up on the cloud, depending on your cloud vendor, perhaps you don't have that, so you can switch those to x264, x265, for example. And Norsk can do that transparently, so you're only having to manage one set of software infrastructure, even though it's running in two dynamic places. I think a really interesting use case, and we've got a couple of customers that do this, is where they're running 24/7 stuff in their on-prem, which, as we said, may not actually be on-prem, but it's almost irrelevant. They're running 24/7 stuff there because those 24/7 bills are the things that start racking up when you're with the cloud providers. But they have the ability to spike their loads up into the cloud. So when they need to launch a few extra channels because there's a particular event coming up where they need more capacity, they can spin those channels up in the cloud. They have a single management infrastructure to do that. They've got a single media server engine to do that. It's very transparent to them, makes their business very dynamic.
Yeah, thank you. And this is an important step towards what are some best practices around when can you choose one over the other. And something that we talked about is the control and the customization, where you have the ultimate control if you have everything on-prem. But Sean, we earlier talked about something that was published a couple of days ago, where a large customer of yours, which is Uber, the mobility company, they announced that they are using your servers, but and your CPUs in a way that is, carrying a lot of customization because they had special requirements. Could you share something about that?
This is a fantastic example. Nope. Okay. This is a really good example where it's kind of a reverse migration. I think what's talked about a lot today is as you pointed out, a lot for GDPR reasons and data sovereignty, is a lot of people coming on-prem, trying to bring some things back for control and customization, as we've all talked about. Uber case was more the other way. They were famously all on-prem, and then they went back into the cloud. And so, but they did it in a very engineered way, right? So they knew that they would be able to get access to the kind of infrastructure that was running their SaaS applications in volume in these cloud providers, and they also were able to kind of, they also have a condensed model where they didn't need to have like a lot of those edge data centers, right? They were able to kind of consolidate their infrastructure in several worldwide data centers. But the engineering that went along with this particular migration, the Uber migration, was still intense. You know, the amount of tuning to get all of that, you know, very SLA driven, so service level agreement driven code to interoperate on those cloud infrastructures took a long time, actually. It took about a year for them to really kind of build that up to a point where it was equal or better than what they had on-prem.
Okay, but I assume that, so this is an example of a huge customer, Uber. So they have a certain buying power, so that not all customers would get that level of customization. So I think for a lot of customers, the problem with the cloud often is that they don't get that customization. Now it's great that we have an example where the opposite is true, but I think for many customers, it's a different story then. No? So did you take these customizations that you made for Uber and integrated them in your product for general availability, or is it still something that is specific to Uber?
No, that's a really good question. A lot of that experiential work, which kind of comes down to code tuning and optimizations. I'm sure Steve you know, you can talk a little bit more about this as well. But all of that tuning is now knowledge that is more generally available, especially when it comes down to just-in-time compilation, you know, scripted languages and all of those sorts of things. A lot of that has to be tuned to an architecture, and you know, being the new architecture on the block, we'll probably get to this a little later, being ARM instruction set based, we have a lot of experience with that kind of tuning, and so yes, now we're making a lot of those key learnings available to other customers through that experiential, you know, sort of development.
Yeah, thank you. Okay, got it. So Alex, on your NetIn card, so you're using ASICs for acceleration of workload-heavy processes that you usually had done in CPU or GPU in this case. So what is your view on the deployment of these machines in servers? Like I know you do a lot with Supermicro, for instance. We have used Supermicro servers as well. What is your angle on how you use, what is the benefit of using Supermicro in that area? What is the big challenge about that, perhaps?
Yeah, so as a hardware company, and we designed this the VPU that can suitable for any kind of the software and hardware platform. So not because we're using the NVMe protocol as the main interface talk to the host, so we can adapt to like a different operation system, different kernel without any effort need to fine-tune the drivers, and also suitable for different hardwares. So with that, so in fact, we're working with a lot of the different server manufacturers. We work with Supermicro was recently because I think one of the advantage that we have with Supermicro is because they are very flexible. So there's anything on the process, they can move very fast, which on some other server manufacturers may be not so fast. That's the reason. But to us, that we see that customer, they demand different servers, right? They work with Supermicro, they work with others, so we can support them all. Yeah.
Yeah, thank you. So GNL is not a huge company. We have 65 employees. So we try to keep the zoo of hardware and software that we use small. And for a very long time, we have just used HPE servers, for instance, because they did the job. But then when we wanted to use NetIn cards, the problem was you can't buy them into a HPE server. They wouldn't allow that. They don't even sell the slides where you put them in. So we discussed it with them, but they were not interested to actually support this. So that brought us to Supermicro, and it was an interesting story because in the end, we ended up with a machine that is more affordable, where we have support for third-party accelerations like NetInt. It's more flexible, and also it came with the Ampere CPUs. So that was a very interesting move there. No? Okay, so, but as we are using these tools, the Ampere CPU and the NetInt cards, and also some other stuff, because some broadcasting clients, they need SDI input, we can only work with that if we have some integration below that, Steve. And that's where you usually help us a lot, because you have to integrate that. So could you tell us a bit more about how you integrate with these different pieces of hardware, how you're doing this, and how you can help customers actually deploy these technologies?
Sure. So Norsk is a very layered architecture. We have various layers within the platform that are responsible for different bits of the system runtime. So most of the command and control within Norsk is written in a language called PureScript, which is a super high-level language, very, very type-safe, and it gives us massive flexibility as we're developing code. We can add new function, and we can know from the compiler very quickly what's working, what's broken. Typically, once the compiler says, yes, that's good, everything works. As you go lower down the stack, you can't use languages like that. We can't talk to device drivers with PureScript. So we switch to C++, Rust, Zig, that sort of thing. And we'll take SDKs from people like NetInt, and depending on that SDK, depending how that's structured, we'll then use an appropriate one of those low-level languages to wrap that SDK up. Within Norsk, we have a subsystem called our Isolated Extensions platform. So the SDK code gets loaded into that. That's an isolated process. And then we communicate back with the main Norsk process via shared memory and Unix domain sockets and so on. So we get superb performance between the stack. But also, if there's an issue in the native code, because native code occasionally does have issues, we have control over what happens when that goes wrong. So if someone dereferences a null pointer, that goes pop. Norsk is isolated from that. It can detect that's happened. It can raise alerts to say, this has happened. What do you want to do?
Great, thank you. Yeah, and so GNL takes these hardware components, the NetInt cards, we have DeltaCast capture cards, and your SDK running on an Ampere server. And so we build our AVPU, that's the machine that is combining that, so that our customers can use the technology on-prem. But again, there are use cases where it's useful to work on-prem a lot, and I think there is the whole cloud hype led to a situation where people thought we must be in the cloud, we must definitely put all our workloads there. I think this is not true. I think we all agree that there are use cases where if you have a steady load, a predictable load, it makes sense to just run it on-prem because the 24/7 operation will be much cheaper, and then offload all things that are spiky, unpredictable, with quick iterations in lab environments. That is something that you should and could bring on the cloud. So for us, it's important that we have a technology stack that can move between these different areas. So we have the machine here on-prem that does all this. And the interesting thing is for us that your software, Steve, your Norsk is a software, it can run anywhere. But with the NetInt cards, we depend on that we have a vendor that has actually these cards deployed. So with great delight, I learned that now your cards are also available in our favorite cloud provider, the Akamai Connected Cloud. So could you share something about that?
Yeah, sure. So I'm very excited to announce that just today we announced that we are partner with Akamai. So our NetInt card is on Akamai's connected cloud right now, and start with the first phase of the deployment. And with that, I think that's you mentioned is very true that the customer not only need on the cloud or only on the prem, but they need both. So in that case, we're also working with partners like Norsk and Ampere as well. So we build a total solution that can be on the cloud, so customer can easily have the same workflow on the prem or on the cloud, right? They're easily to migrate and to handle the spec demands.
And can you already share, is there a small set of locations where they will be available? Will they start in the US, or do you know if they will launch already in Europe?
Okay, so I don't want to steal the thunder from Akamai, but I know that this is a global launch. So for the first phase will be like in the US, in the Europe, and also APAC, 3 main regions. Yeah, That's the first step.
Thank you. Okay, then I would like to come back to a point, Sean, that you asked for a couple of minutes ago, and that is the question, so why are we using Ampere and ARM CPUs in the first place? Because that's not very typical or not the complete new normal. So when we were looking for a CPU infrastructure or a family, my team first looked into Intel and AMD because we had been using it for a very long time. But we are also heavy Mac users, so we were familiar with ARM as a technology, and we knew that if you look at the whole market of mobile devices and of IoT devices, that's something where ARM has been strong and has a huge market penetration. So I know what brought us to Ampere and to ARM CPUs, but I think you will have discussed this with many, many customers. So I'd like to hear your view on why do people choose ARM CPUs from Ampere?
Okay, Alex, this is a dangerous question. Yeah, I could go really way far back, but no, Ampere was founded with a vision, right? We wanted to start to deliver a processor to the market that the cloud had started to ask for decades ago. And really what it came down to is a linearly scalable architecture that essentially grew or shrank with your workloads and always provided a very predictable, deterministic execution. For a lot of cloud native applications that are super SLA based, so they need that predictability of execution. Things like hyper-threading and power management and turbo and all of these features that came with x86 are actually counterweights to that predictability and that determinism. So we came in and we said, look, we kind of don't want it. We did away with all that. We have a very, very linearly high core count architecture, right? So that was the other thing. You need a lot of cores. And so that's kind of what we built. And we built it originally with the cloud in mind. Now, beginning in like a year and a half ago, we started talking to a lot of media and entertainment and CDN customers and these types of folks. And when I described our architecture like I just did, they were like, wait a minute, that's exactly what we need. Because now I don't have to go through and turn off all of these other things and really sort of do, code and hardware gymnastics to make the platform work for my workloads. So, that's, I think, a big piece of what has started to, kind of give us more and more traction and notoriety in this particular market. And we appreciate, of course, G&L and Norsk for actually having ported to the architecture to begin with, and of course our partnership with NetInt, because all of these things are complementary, right?
Yeah, and we got a lot of questions of why do you need so many cores? So the first reason is because we can, and looking at this gorgeous HTOP in Linux is beautiful if you have 128, and soon more cores than that. So I know you're going to 192 and 256 on the roadmap, so that's amazing. And on the other hand, we are using the NetInt cards to actually bring down the power that we need to do the heavy load for encoding and for sizing and for cropping. So people ask, what's left? What are you doing with all these cores? And we're just now rolling out a set of these servers in a large project for an EU entity. And in that case, what we have is we get content that is coming via SDI. So we have a lot of SDI channels, and the SDI decoding still needs a lot of work to be done in the CPU. We also have content that is interlaced, so we have to deinterlace it, something that we don't have on the card, because you wouldn't buy something new today that supports interlacing, but still we got these signals, so we need to do that in the CPU. And we also, in this specific case, each video channel comes with 32 audio channels, and they also need to be worked on. So for us, it's very handy to have 128 cores, and there are some use cases where we even would love to have more, so we're waiting for that to come. That said, I know that Ampere has invested a lot also in helping the video community to improve very popular products so that they can run better on ARM. Because if you go into video encoding and video topics, you have to squeeze out the last bit of performance from CPUs. And so the way that the ARM CPU works is different from Intel. You have the RISC system versus CISC system, so a reduced set of instructions. They run in a different way. So I think it's important that somebody who knows exactly how the CPU is working helps the community to optimize their tools, like FFmpeg, for instance. So is that something you could share some more about it? Yeah.
Yes, and this is definitely an area where it's not just about the instruction set, too, right? I mean, the ARM instruction set has been around for a long time, as long as x86, really, but not in this market, right? So the server market in general and a lot of server workloads have more come lately to this architecture. And so there's the obvious, instruction set change that has to be made, which can be done with compilation or with like scripted languages with already built, just-in-time compilers and things like that, Python, Erlang, Java, all these things. So we've been working in those sorts of projects, many of them open source, actually all of them open source, for quite some time, and putting optimizations in for that architecture. But it also comes down to encoding. A lot of encoders have inline assembly, and so that you have to go and enable all that kind of thing. But more to the streaming, kind of audience, things like FFmpeg or GStreamer, these things also have to be, really kind of tuned to get the most out of the architecture. And I would say that one thing there is it goes beyond, again, the instruction set. It's really about that scale out. That 192, which is, by the way, now available through Supermicro, that's a lot of cores. And so, you're also tuning for that scale out architecture and also the caching architecture that we utilize, which is very different than x86. But I'll leave that for another time.
Okay, thank you very much. Yeah, and for us, the interesting thing is that the machines that we picked and the components that we picked from your companies together with the software allows for a very versatile platform that we now have. And we are using this for a lot of media processing workflows. We are also talking about customers using it just for on-demand transcoding because it's so versatile. And if we remove all the stuff that is related to video engineering, we still have a machine that we can use for content delivery. So we have been trying to use it in just delivering our audio streams that we have, delivering it as a CDN server. So it's for me as a managing director, it's a very interesting platform to build on and to combine it in a very flexible way. So thank you all for your contributions. We have here an integration example that I'm really proud of. So thanks for all your work for that. And now, thank you for the discussion here. Happy to have you. And I'm now honored to open the bar for the happy hour. So thank you very much and have a great evening. Thank you.